Welcome to this explainer. I'm absolutely thrilled to have you here today because we're looking at a massive, literally existential shift in the software engineering world. The way you write code is becoming obsolete. By next year, basic coding skills won't be enough to stay employed. If you're still stuck in messy old school data formats, you're frankly falling behind. The reality is, our jobs are shifting from typing out rigid instructions to orchestrating autonomous reasoning engines. You need to master F syntax right now to talk to AI agents, or you seriously risk being replaced by 2027. Okay, let's dive into this because that quote right there is the stark reality we're dealing with. Basic coding skills simply won't cut it anymore. If you're still anchoring your daily workflows in verbose, legacy data formats, you are already falling behind the curve. We're approaching a hard deadline in 2027 where interfacing effectively with AI agents isn't just a nice bonus, it's going to be an absolute prerequisite for professional survival. So, what does this all mean? Well, it brings us to a pretty uncomfortable question. Will you be replaced by 2027? Autonomous agents, they're no longer just basic code completion assistants. They are actively taking over complex multi-step tasks. But to do that effectively, they require massive amounts of context. If your current skill set is locked into legacy architectures that literally choke these agents, your role is absolutely at risk. You have to master the syntax that allows you to actually talk to these AI systems. Which brings us to section 1, the fatal flaw. In legacy semantic parsing. For decades, we've relied on traditional JSON-heavy architectures as the undisputed standard for data exchange. But today, they're creating a massive, crippling latency bottleneck for AI workflows. Think about bloated, deeply nested JSON and HTML structures. They're just full of heavy syntactic noise, tags, class attributes, CSS embeds, and endless nested brackets that give us human developers a headache just trying to trace them. And for an autonomous reasoning engine, it's incredibly reasoning acting loop making multiple tool calls, forcing it to spit out strict, deeply nested JSON adds hundreds of milliseconds per interaction. It completely cripples high-speed agentic execution. Let's look at the actual math here. Time to complete response equals time to first token plus your output tokens divided by output tokens per second. This formula literally proves that reducing output tokens is a computational necessity. Every single extra bracket or JSON tag you force an LLM to generate directly inflates your response time. A leaner syntax isn't just a nice-to-have anymore. It's absolutely mandatory for speed. So the crucial point is we need a solution. And that brings us to section 2, the anatomy of object kinetic functional syntax. The answer we've been waiting for is the Open Knowledge Format, or OKF, introduced as an open standard by Google Cloud back on June 12, 2026. This is the leaner recursive alternative the industry has been desperately needing. So, what exactly is it? It's simply a directory of markdown files with YAML front matter representing organizational knowledge for AI agents. That's the whole shebang. It's beautifully simple. Just files, just markdown, and just YAML. There are no proprietary SDKs, no complex databases, and zero massive vendor lock-in required to make this work. It's honestly like a brilliantly simple puzzle. Let's look at the anatomy of a single OKF concept. You have one markdown file per concept, say a database table or an API endpoint. You drop a tiny YAML front matter block right at the top. And the best part, there is exactly one required field, the type. Everything else, title, description, tags, is entirely optional. The files are interlin using standard markdown links. Because the requirements are so incredibly minimal, the friction to adopt this across an entire organization is practically zero. Now, you might be wondering what this actually achieves. Well, by utilizing OKF, you're engaging in what is called kinetic intent mapping. Instead of writing rigid, frozen database schemas, you're actually capturing the active momentum of system operations. You map the active intentions and locations of your system. Mastering this completely shifts your role from simply typing out rigid lines of code to seamlessly orchestrating fluid machine execution. Let's move to and see how this builds into Section 3, Bridging Human Intent and Autonomous Execution. Look, one of the biggest challenges right now is the universal dread of writing documentation. We all know wikis are for humans and code is for machines, right? Well, OKF acts as a perfect dual readable translation layer. The exact same marked on file an engineer reads in their editor is ingested natively by an AI agent as high fidelity context. And the token savings are absolutely undeniable. The same exact data that eats up nearly 14,000 tokens in JSON takes just over 11,600 in Markdown. That proves Markdown is up to 15% more token efficient. When agents process for cursive OKF logic instead of standard nested objects, you're directly reducing your API billing and your latency. I love this brilliant insight from Andre Karpathy. He said, LMs don't get bored. Don't forget to update a cross-reference. The bookkeeping that causes humans to abandon personal wikis is exactly what LLMs are good at. And he hit the nail on the head. AI agents are perfectly suited to build and continuously maintain these OKF wikis for us. They can read your database, generate the OKF markdown, and keep it updated forever without ever complaining. Which takes us right into Section 4, optimizing code bases for the 2027 agentic shift. Moving from theory to practice, we have to figure out how to actually dismantle our legacy technical debt. How do we refactor our repositories so high-velocity AI integration is possible? We absolutely need our code bases to treat autonomous agents as first-class citizens. The roadmap for this is called the Context Ops Lifecycle. First, capture extract patterns from your active code. Second, version track every single update as a standard. Git commit. Third, distribute. Share these OKF bundles across your repositories. And fourth, audit. Run chronological lint passes using the index.mmd files to catch any drift. This is exactly how you govern a codebase where AI agents are your primary collaborators. And that leads us to our final section, Section 5, the competitive survival gap. And this brilliantly illustrates the harsh reality we're facing. We are predicting an imminent massive divergence in the industry by 2027. On one side, you'll have OK native developers designing cutting-edge knowledge infrastructure. On the other, developers stuck in traditional semantic paradigms facing literal career obsolescence. Think about the costly legacy paradigm: brittle JSON adapters, tribal knowledge lost in Slack threads, huge token latency, and manual refactoring. Contrast that with the highly efficient OK-FAT approach, raw file directories, version-controlled Git repos, sub-second reasoning loops, up to a 50% reduction in context costs, and autonomous migrations. It is a literally night and day. And this isn't just some niche trend. The specific enterprise sectors demanding OKFY right now are expanding like wildfire. Enterprise data clouds like Google's BigQuery, they natively ingest it. Sovereign AI and GDPR compliance stacks absolutely require it because the files stay local. Site reliability engineers use it for instant automation, and it's already the standard formatting layer for distributed agent protocols like MCP. It is rapidly becoming a mandatory requirement for lead technical roles. Though I want to leave you with this final provocative thought: read the OKF spec today, or will your agents be reading your deprecation notice tomorrow? The transition to agentic software engineering isn't a future concept. It is happening right now. Embrace this lean logic immediately. Create an OKF file for your team today and ensure your relevance in the next era of computing. Thanks so much for joining me on this explainer. Now get out there and go build that knowledge infrastructure.